Dear students, in this section we are going to discuss on the concept of scatter diagram, uses of scatter diagram and types of scatter diagram. This episode consists of the following sub-modules: Introduction, concept of scatter diagram, methodology of scatter diagram, uses of scatter diagram, parameters of scatter diagram, types of scatter diagram. Next we are move on to the introduction part. Identification of causal relationship among different characteristics is an important concern of any scientific investigation. Social scientist on several occasions wants to know whether a series of values vary directly or inversely with another series, which called as correlation. The factor which is supposed to be the cause is known as the independent variable, and the one which is supposed to be the effect is known as the dependent variable. Thus, the variation in dependent variable may be explained in terms of the variations in the independent variables. In case there exists a causal relationship, both the values of independent and dependent variables will vary together. If an increase in the independent variable tends to cause an increase in the dependent variable, the relationship is said to be positive correlation. For example, good rainfall causes a higher agriculture production. On the other hand, if an increase in the independent variable leads to decrease in the value of dependent variable, which called as negative correlation. For example, good medical facilities causes to reduce the number of deaths. Sometimes there is no relationship between the variables, for example, literacy and rainfall. Therefore, measurement of the degree and direction of relationship is useful to explaining the variations in different phenomena. Mainly, there are two ways to explain the correlation. There are graphical method, mathematical method. So, graphical method is subdivided into two groups. They are scatter diagram, second one is simple graph. So, in the same way, mathematical method is also subdivided into three groups. They are Carl Pearson's coefficient of correlation, second one Spearman's rank correlation, third one methods of least square. Scatter diagram is a type of graphical form to show the degree of relationship. Okay, next the concept of scatter diagram. Scatter diagrams or dot diagrams is a chart prepared to represent graphically the relationship between the variables. So, the x variable is plotted on the horizontal scale and y variable on vertical scale. Only one dot could be plotted for each set of the two values. The way in which the dot lines on the scatter diagram shows the type of relationship. If these dots shows some trend either upward or downward, the variables are said to be correlated. The data is displayed as a collection of points, each having the values of one variable determining the position on the horizontal axis and the value of the other variable determining the position on the vertical axis. The kind of plot also called scatter chart, scatter plot, scatter graph and scatter diagram. These are all the different names of scatter diagram. For example, the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 12 days. This is the data of temperature and ice cream sales. The same data is shown on the scatter plot. So, in the scatter plot, it is showing the positive correlation between temperature and sales. Increase in the temperature, there is an increase in the sales. We can easily identify with the help of this scatter plot. So, that is why the scatter plot is very important to find out the relationship between any two variables. It could be temperature and sales of ice cream, or it could be any other things. Lines of best fit. A line of best fit can be drawn using the least square method. If the points are falling very close to this line, there is a high degree of positive correlation. If they lies very far away from this line, shows that not so much, means less dependent. So this can also we can see with the help of diagram. So this diagram is coming in the screen. So that line is showing the line of best fit. So based on that line of best fit, we can identify there is a perfect correlation or there is a negative correlation. Try to have the line as close as possible to all points and as many points above the line as below. Lines of best fit. What do you mean by lines of best fit? How to construct that lines of best fit? Lines of best fit is nothing but is a line that goes roughly through the middle of all the scatter points on a graph. The closer the points are to the line of best fit, the stronger we can say the correlation is. The line of best fit is drawn so that the points are evenly distributed on either side of the line. There are various methods for drawing this precisely, but you will only be expected to draw the line by eye. You may be asked to comment on the nature of the correlation. This means you will be expected to say whether there is a positive, negative or no correlation. Using terms such as strong, moderate or weak will give a clearer indication of the strength of the connection. When drawing the line of best fit, use a transparent ruler so you can see how the line fits between all the points before you draw it. Next, we are moving on to the methodology of scatter plot. Scatter plots are similar to line graphs in that they use both horizontal and vertical axis to plot data points. However, they have a very specific purpose. Scatter plots show how much one variable is affected by another variable. Scatter plots usually consist of a large body of data. The closer the data points come when plotted to making a straight line, the higher the correlation between the two variables or the stronger the relationship. If the data points make a straight line going from the origin out to high x and y values, then the variables are said to have a positive correlation. If the line goes from a high value on y axis down to a high value on x axis, the variables have a negative correlation. So the same thing it's coming on the screen. We can easily identify A is showing positive correlation and the same way B is showing negative correlation. Next, how to make a scatter plot, that is very important. In this section shows that how we do the diagram with a spreadsheet form. So there are different steps. In the first step, draw an L form in the sheet. Make a scale units at even multiples such as 10, 20, 30, etc. so as to have a scale system. Next step, in the second step, on the horizontal axis, it means it known as x axis, from left to right, you place the independent or cos variable. In the step 3, on the vertical axis, it known as y axis, from the bottom to top, you place the dependent or effect variable. Next, in the step 4, plot your data points at the intersection of your data plots of the x and y values. For example, x is y, y is 2, go right 5 spaces and then go up 2 spaces to plot the point, and after that find out the degree and direction of the relationship between the variables. Next, we are moving to the uses of scatter diagram. What are the uses are there in scatter diagram? So, the scatter plot provides a graphical display of the relationship between two variables. It is useful in early stage of analysis when exploring data before actually calculating a correlation coefficient or fitting a regression curve. For example, a scatter diagram can help to determine whether a linear regression model is appropriate or not. A scatter plot is a dot diagram drawn to compare two sets of data. It can be used to look for connection or a correlation between these two sets of data. It is especially useful when there are a large number of data points. It is also useful to examine the cause and effect relationships and to search for root causes of an identified problem. Next, we are move on to the parameters of scatter diagram. There are 4 important parameters in the scatter diagram. One is correlation, slope, direction and intercept points. First one is correlation. Correlation, it shows the relationship between two variables by displaying data points on a two-dimensional graph. It measures how well the data line up. The more the data resembles a straight line, the higher the correlation to each other. The second parameter is slope. It measures the steepness of the data. The steeper the data slope, assuming the correlation is good, the greater the importance of the relationship. A change in x variable will have a larger impact on the y variable. So, in this way, slope is also very important to identify the relationship between two variables. The third parameter is direction. The x variable can have a positive or a negative impact on the y variable. As one factor goes up, the other goes down. In a positive correlation, both factors will move in the same direction. The graph is displaying in the scene, it shows the positive correlation. Line moves from the lower left towards upper right. The negative correlation moves from the lower right towards the upper left. Next, we are move on to the last parameter of the scatter diagram, that is interception point. Where a line drawn through the data crosses y-axis. For a positive correlation, it represents the minimum y value. For a negative correlation, it represents the maximum y value. So, these are all the parameters of scatter diagrams. Next, we are move on to the types of scatter diagram. There are different types of scatter diagrams. There are perfect positive correlation scatter diagram, perfect negative correlation scatter diagram, limited positive correlation scatter diagram, limited negative correlation scatter diagram, next zero correlation scatter diagram. The last one is complex correlation scatter diagram. Next, we are move on to the one by one. Perfect positive correlation scatter diagram. This diagram shows that if an increase in the y variable correspondingly increase in the x variable, you can see in the screen. So, this is the perfect positive correlation scatter diagram. Okay, next, the second one is perfect negative correlation scatter diagram. When an increase in one variable is always followed by corresponding proportionate decrease in another dependent variable, then the relation is said to be perfect negative. So, in the screen, the negative correlation graph is coming. So, this is the negative correlation graph. Next, limited positive correlation scatter diagram. When an increase in one variable is always followed by a corresponding but non-proportionate increase in other related variable, then the correlation is said to be positive limited degree correlation. So, in the screen, the diagram is coming. So, fourth one, limited negative correlation scatter diagram. The limited negative correlation scatter plot shows when an increase in one variable is always followed by non-proportional decrease in the other dependent variable. It called as limited negative correlation scatter diagram. So, in the screen, the limited negative correlation scatter diagram is coming. So, the next thing is zero correlation type of scatter diagram. Here the name itself is showing there is a no relationship. If value of one variable is not related with values of other variables, then we can call this relationship is a zero correlation. This can also we can show it on scatter diagram. So, in the screen the zero correlation scatter diagram is coming. So, in the last one, complex type of scatter diagram. The value of y seems to be related to the value of x. but the relationship is not easily determined. So this relationship scatter diagram called as complex type of scatter diagram. So the graph it's showing in the screen. Conclusion. We come to the last segment of this session is conclusion. So the scatter diagram are very useful to many scholars, especially geographers, which explaining the kind of relationship in various spatial phenomena. It gives us an proper idea of the relationship between independent and dependent variable of spatial factors. So in this way, scatter plot is very important analysis for geographers, not only geographers and also other social scientists. Thank you.